This is our third and final video on simultaneous equations, looking at the elimination method. Okay, we use the elimination method when we see our linear functions in the form expressed here. Okay, and I'll show you why in a moment. I'm going to rewrite them out and call that equation 1. Call that equation 2. And simply with the elimination method, you try and get rid of either the x or the y. And from that, I can see that we have the same value for x. So I'm just going to subtract both equations. Okay, so I have 3x minus 3x at 0. 2y minus negative y becomes plus 3y. 8 minus 5 is 3. So I'm left with 3y equals 3. Now I need to divide both by 3, and I'll get that y equals 1. Now I'm going to substitute y equals 1 into equation 1. Okay, so equation 1 is 3x plus 2y equals 8. So I'm going to rewrite that again, substituting y equals 1 into. Okay, so then expanding that out, 3x plus 2. Remember with the brackets directly behind it, it's 2 multiplied by what's in the brackets. Because it's 1, it's 2 times 1 is 2 equals 8. Once again, we want to get the x to the left-hand side and the numbers to the right. So we need to do the inverse function again to get them over there. And I'm left with 3x equals 6. My final step, divide by 3. And x equals 2. So our solution for our point of intersection, because remember that's what we've found, our x value is 2, our y value is 1. And we can substitute those in to check that they are correct. Moving on to example 2. Once again, I'm going to rewrite the equation again. Call that equation 1. Equation 2. This time you'll notice we don't have an x value that's the same or a y value. Sometimes we can get rid of the y straight away. Others we can get rid of the x. What we can do though is manipulate a whole equation. Because this top one has got 3x in it, I want to get the bottom one to have 3x in it. And to do that, I need to multiply equation 2, that's all of it, by 3. Okay, so that would give me 3x. Negative 2 times 3 is negative 6y. And negative 1 times 3 is negative 3. I'm going to call that equation 3. So now I'm going to go equation 1, subtract equation 3. And I'm going to rewrite that out again so we don't have anything in the way. Equation 1. Equation 3. And we're going to subtract them, we said. So 3x minus 3x is 0. 5y minus negative 6y is positive 11y. 8 minus negative 3 is 11. So you can see again we're going to divide by 11. We get that y equals 1. Once again y equals 1. And we're going to substitute y equals 1 into, let's say, equation 1. So I'll rewrite it, 3x plus 5y equals 8. So 3x plus 5, we're saying we found that y is 1, equals 8. So expanding that out, 5 times 1 is 5. We need to get rid of the 5 to the other side. So we need to subtract 5 from both sides. So we get 3x equals 3. And I think you can see what x will equal. So once again, you can check that it is our point of intersection, but we can say that it is 1, 1. So what we did there, we tried to identify, we needed to identify how we could get rid of the x. We could have done it with the y, but I just saw straight away that this would need to become 3 to eliminate the x. So I had to multiply the whole equation by 3, which created a third equation. And then I went equation 1, subtract equation 3, and rewrote it out down here so it's a lot neater and I can follow it from there. Looking at the final example, okay, I'm going to rewrite it out again. Equals 1, call that equation 1. Equation 2. Okay, once again, we don't have any x values are the same or y values are the same. However, I can see that this is 2 and at the moment this is 1y, so I'm going to multiply the first equation by 2 and we're going to create a third equation. So y times 2 is 2y, negative 3 times 2 is negative 6x, 1 times 2 is 2. Call that equation 3. Now we've got the same values for the y's, so we are going to try and eliminate the y's. So I'm going to go equation 2 minus equation 3. I'm going to rewrite it over here. And we are subtracting 2y minus 2y is 0, 5x minus negative 6x is plus 11x, 13 minus 2 is 11. So therefore we have 11x equals 11, and I think you can see what x is going to equal. X equals 1. Now sub x equals 1 into, let's go equation 2 this time. So 2y plus x is 1 equals 13. So then we get 2y plus 5 equals 13. We need to get rid of that 5, so I'm going to subtract 5 from both sides. We get 2y equals 8. Divide both sides by 2. Y equals 4. So our point of intersection is, our x value is 1 and our y value is 4. So the first thing we need to do when trying to solve a simultaneous equation using the elimination method, if we have pronumerals that are the same value, so our x values are the same or our y values are the same, we can simply try and eliminate them by subtracting them from each other. Okay, sometimes you'll need to add to each other to get rid of them. Okay, you'll need to identify that when you are solving. Then at times when they were different, so for example here, we had to create a third equation. Okay, so that's when you'll need to create a third equation, when you're trying to get the same coefficient or the number at the front of the pronumeral.